Hey guys, welcome back. This is bimzycodes, and in this lesson we're going to be going over Unity's inbuilt physics system. So jumping straight in, let's take a look at our obstacle, one of our game objects inside the hierarchy. So looking at this, we can see all of the components that's been added to this game object, one of them being the box collider. This box collider is a default component that Unity provides, and it's part of its extensive physics system. So to take a look at the rest of the components that Unity offers as part of its physics system, we're going to want to go ahead and click Add Component, and then hover down to the Physics. We've also got a Physics 2D option, but because we're using 3D game objects in our scene and we want them to interact in a 3D environment, we're going to want to select the Physics option. So these are all of the components Unity provides for its physics, and we're going to go ahead and want to add a rigid body to our game object. So what the rigid body component does is it allows us to simulate some physics behavior right onto our game object. So you'll notice here we've got the using gravity flag, and we can just tick that on or off. So you'll notice if we hit play now, the game object will actually simulate some gravity. So it'll start falling, and once it lands, it'll sort of stop on this ground here. Now, an important thing to note is for something to simulate some physics, we need to have a rigid body and a collider of some sort. So this game object comes default with the box collider already. And the reason why it stops on our ground here is because our ground object comes with a mesh collider by default when we create that one as well. So we're going to go ahead and remove this rigid body from this game object. So just right click rigid body and remove component, and we're going to add it to our droppables game object here, or our droppables prefab rather. So go add component, physics, and add the rigid body. So just make sure it's ticked using gravity. Now all of our droppables should have box colliders on them. So once we hit play, they'll all start falling from the sky. Now that's pretty cool. You'll notice how the boxes in the center sort of bounced off the player. That's because the player also has a collider on it and the physics is just simulated. Another thing we can do is start messing around with some of these properties on the rigid body itself. So what I'm going to do just as a demonstration is add some drag to these game objects. So we want the obstacle probably to be the fastest game object falling from the sky. So let's go ahead and change the drag on our collectible 1. And our collectible 2. Now this will just allow us to have more time to react to catching the obstacles as they fall from the sky. So you'll see straight away that they sort of all fall at different move speeds now because they've got different drag values. We can also change this mass value, which sort of changes how they interact when they crash into each other or they bounce around. That's just sort of the weight of the game object. So the game we're making is built in a 3D environment, as you can see, but the way we want these blocks to interact is sort of along this 2D plane here. So what we can do to accomplish this is if we go to our droppables prefab, we can actually constrain this droppable on the Z-axis, which is just this blue axis here, if you see. And that way, when the blocks fall and they interact with collisions, they'll make sure that their Z positions stays whatever it was defined at. So it was 10 originally, and at the end it was also 10. So we've sort of constrained it to that axis on that position. So let's start implementing the physics for the rest of the game. So we can go to player, add component, and let's just type rigid body in here. And we're going to want to constrain this one along the Z axis as well as the Y axis, because we don't really want this player moving up or down. We just want him going left or right. So let's do that now. The next thing we need to do is add some collision detection along the bottom here. So we're going to create a new game object, 3D object, cube. And this is just to detect when these droppable objects are falling from the sky. We need a way to remove those objects. So we're going to create a cube that's going to be in charge of detecting the collision and then deleting the game object as it hits the ground. So let's call this droppable destroyer, and we're going to want to make this droppable destroyer the same size as this ground. So let's just copy this transform, paste that one in, paste component values, and that'll just copy those. Now by default the plane is 10 times larger than a cube, so let's multiply this x by 10 and this y and this z by 10 as well. Perfect. Now it looks a bit ugly because we've got this cube being rendered. So to stop this cube from being rendered, let's just go ahead and remove this mesh renderer component, and you'll notice straight away we no longer see that cube. We do, however, still need its collider, so you can see that over here. Now we just want to move this one down underneath the ground. So I believe that was negative 4.5. Maybe negative 4. We have to make it so it's right underneath. All right, that looks pretty good. Negative 4. Now the reason we can't actually use the ground as a reliable collision detection is because it's so thin that some of the cubes, if they're going too fast, they might actually go straight through the plane without detecting the collision at all. So that's why we want to use this droppable destroyer, because it's got a bit of height on it. Now you'll notice our hierarchy is getting a bit messy, so why don't we go ahead and clean that up by creating an empty game object and call this one droppables, and we can go ahead and throw all of our droppables in there. Let's reset this to 0 that one out. It's always good to have like blank game objects set to 0. It's just good practice. And we'll throw all of our obstacles in that droppables game object. So select all these guys, throw them straight into droppables. That's looking pretty clean. Droppable destroyer, ground. Can actually make this droppable destroyer a child of the ground, or vice versa, just so they're sort of paired together. Now when we move this ground object, you'll notice the droppable destroyer moves with it. So that's why we want to do that. And if we move this droppables game object, all the droppable components will as well. So the next thing we want to do is fire an interaction between these droppables and whatever game object they're hitting. So we're going to have 2 interactions, one with either the player or one with this droppable destroyers. So to do this, we want to first create a droppable destroyer script. So just click scripts folder, create C# script, and let's make a droppable destroyer. Now you'll notice on this prefab as well, just here on the droppables prefab, we've got the box collider. Now on this box collider, its job is to handle like collision detection essentially. And you'll notice if we play the game, these boxes or these obstacles will just fall until they hit the ground, and they'll stop right there when they hit the ground. What we can actually do is select is trigger, and these droppables should, instead of hitting the ground, just fall straight through. Now what's happening here is they're still firing their collision detection. They're just not being handled as a proper game object. Now this is handy for stuff like bullets if you want it to go through walls. There's a lot of different scenarios that we can use this is trigger flag. So we're going to want to keep that is trigger for now. And then we'll jump into the code and handle the collision detection with these droppables and the ground. So let's jump into the code and open our droppable destroyer script. So the first method we're going to want to create is the Ontrigger enter method. So we're going to type out private void on, and you can see it here in the list. So if we just select that one and press enter, it'll create it for us. Now what this Ontrigger enter does, if we jump back into Unity, you'll notice with our droppable game object, we've selected is trigger here. So when this droppable game object's falling and it intersects the droppable destroyer collider, which we can see highlighted in this sort of green outline, is just the ground object. As it intersects, that Ontrigger enter will fire in our code. So at this point, we want to destroy that game object. So it's super easy to do it from code. So let's just jump back into the script and do that. So to test this, let's do an if statement here. And you'll notice here we've got collider other. So this collider is the collider that's entering our current box collider, because this script is going to be sitting on the droppable destroyer game object. So we're going to run other dot tag. Now we've already set up the tag on our game objects to be droppables. And I'll show that in just 1 second. So droppable. So if the tag is a droppable, we're going to want to destroy the other, which is the collider dot game object. So jumping back into Unity, we can see here all of these are tagged as droppable. So we're checking if what's entering our droppable destroyer is this tag droppable? If it is, we're going to want to destroy the collider's game object, which should be this game object here, whatever's falling through the floor. So to test this, let's run the game. And you'll notice as they hit the ground, they should be disappearing. Maybe not. Oh, I spelled droppable wrong. So let's just capitalize that one. Make sure we always spell this word for word, otherwise you'll get errors. So droppable is capitalized there. And it doesn't seem to be working. Oh, I didn't actually add the script. Wow, my bad. Let's just drag that one onto there. Droppable destroyer. And now you'll notice the droppables are getting destroyed and they disappear as they hit the ground. So finally, let's convert the player's movement system from its current transform.translate to using Unity's physics system. So let's jump back into the code, double click the character controller, and you'll see here we're using the transform.translate to react to the player's input. So a lot of this code is still correct, but let's just comment this out for now. And what we want to do is actually grab that rigid body component here in the update loop. So let's do get component. Now we want to use these sort of triangle braces, and let's grab rigid body. So that's grabbing that rigid body, so the physics interactor, and we're going to want to add force to that. So a lot of this code is still correct here, so we want to grab this input still, so we want to grab that horizontal input. So that is, remember, in the range of -1 to 1. So if we're not pressing any buttons, it'll be 0 by default. Let's grab that vector 3 right and multiply it by this, so we're going in the right direction. And then let's also multiply that one by move speed. Cool. This code should work for us. So let's jump back into our game. And with the physics system, the benefits of using this for our movement on the character controller is there's usually some acceleration and deceleration on this character. So he's looking a bit fast and his stopping speed is a bit slow. So let's just fiddle around with those properties a little bit and see if we can find something that we like to use. So I'm just going to set this drag to 10 for now, and let's move this move speed up to 100. I think those look about good. So just play your game, see if you get a feel for the character, and just set those values to whatever you like, but this is what I'm going to have them for now. I think that plays quite well. So let's jump out of play mode and set those ones up again, just so it's actually saved to our game. So that was 10, and this was 100. Great, I think that wraps up this lesson. Thanks for watching. See you guys later.